In this question, we're going to solve for x, and we have 2 divided by x squared minus 9 in the denominator, plus 5 over x minus 3 is in the denominator, is equal to 3 over x plus 3 is in the denominator. Well, in order to simplify this down and solve for x, or isolate x by itself, what we need to do is look at each one of these fractions and see if we can get a common denominator. But first I can factor this out. X squared minus 9 factors into two binomials. One's going to be x plus 3 and then the other one's going to be x minus 3. So let's just start factoring this out. We have 2 over x plus 3 times x minus 3. That's simplifying or factoring out x squared minus 9. And then we have plus 5 over x minus 3, that's all together, so we can put that in parentheses, is equal to 3 over x plus 3. Well, x plus 3 is also in parentheses because that goes together. Now, in order to solve for x, what I can do is find the common denominator. Well, when I look for common denominators, I look to see if all of these terms were in a bag or a grab bag. I'd want to take as much as I can, but without having anything repeated. So I look, in my bag is going to be this x plus 3, in my bag is going to be x minus 3, and same with x minus 3 and x plus 3. Well, if I grab out of the bag, I want to be sure that I have just one of them. Well, I already have an x plus 3 here and here. Well, I only need to take it one time because I already have it. So what the common denominator is, for all of these fractions, is so far we're going to have x plus 3. And then also in my bag I have x minus 3. Well, that's good to have because I don't have that already. And I already have a repeat of it, so I just need to take it one time. So the common denominator is going to be x plus 3 times x minus 3. Now what I'm going to do with that common denominator is multiply everything by that, so that I can do what's called clearing the fractions. So I'm going to multiply every single one of these fractions with x plus 3 times x minus 3 all over 1. So I'm going to take this whole thing and multiply by x plus 3 times x minus 3 all over 1. Well, when I simplify it down, if I have x plus 3 on top and also on the bottom, those would cross out. Same with x minus 3. So what I'm left with on the first fraction is just 2, because I've cleared the fraction. On the second fraction, I look at, well, x minus 3 is on top and also on the bottom. So I could cross those out, and I'd be left with 5 times parentheses x plus 3. Now the parentheses are important because we're going to be using the distributive property. And then I see an equal sign, and then I'm going to do the same thing. I'm multiplying x plus 3 times x minus 3 times 3 all over x plus 3. Well, the x plus 3's on the top and the bottom cancel each other out, so I'm left with 3 times x minus 3. So when I simplify down, I need to use the distributive property. So as you can see, I've already cleared the fractions because over each one of these fractions would be 1 anyways. So let's use the distributive property to simplify down. So I get 2 plus 5 times x is 5x, and then 5 times 3 is 15. And then we have 3 times x, which is 3x, and then 3 times a negative 3, which is a negative 9. Now what I do is combine all values together. I know on the left side 15 plus 2 is 17, so on the left side I have 5x plus 17, and on the right I still have 3x minus 9. Well, I can move the 3x over by subtracting, so I'm left with 2x plus 17 equals negative 9. Well, solving for x, meaning isolate x by itself, I'll subtract 17 from both sides and I'm left with 2x is equal to negative 26. Dividing by 2 on both sides, I'll get x is equal to negative 13. And that's isolating x by itself or solving for x. Now I can always check my work by taking negative 13 and plugging it back into my original equation where I see x. and simplifying down. So it's a way of checking my work. So I could take 2 divided by, well, negative 13 squared minus 9, come up with a number for that, and then take 2 divided by that number. Then we're going to take that number and add it to 5 divided by, well, negative 13 minus 3. So 5 divided by negative 16. You'll come up with a number, add these two numbers together, and then see if that number that you get is equal to the same thing as 3 over negative 13 plus 3, or 3 over negative 10. And if they work, if it simplifies down and works, you can always check your answer to make sure they're right. And in this case, we are.